Hey guys, so till now we have covered almost this section of the collection framework. We covered list, then in the last video we wrapped up the set, including hash set and linked hash set. There are implementations that we need to cover like tree set, which will be covered later. In this video we are going to start the discussion on the map. So as you can see in this diagram, map is not connected to the collection framework. So there is no hierarchy between collection and the map. As you can see in this diagram, they have their own hierarchy. Map, then the exact implementations of the map interface, which is hash map, linked hash map. Then we have another category, sorted map, same as sets, navigable map, and the tree map. So what is a map? Map belongs to the category of dictionary. What that means is if we go back to the list and set, and if we try to remember how we add elements to a list or to a set, so we simply add a value. For example, list.add1 or set.add2, things like that. Now think about it. These collections, they hold the values, but how do we get the value back? The only way is to basically iterate the collection. In case of list, if we know the index, then we can get the element by the index. But that is not possible with the set. In general, we'll have to iterate the collection and we'll have to see, okay, if this is the element that we need, it's fine. Otherwise, keep looping. So that's where dictionary data structure or dictionary category comes into the picture. What dictionary does, it has a key and a value. So when we are adding a value to the map, we are not adding just the value, we are also adding the key. What that means is instead of a value directly, we add an entry to the map, and this entry is basically a combination of a key and a value. After adding the entry to the key, if we want the value back, we can say get me the value by this key. That is the benefit of the map. The second benefit of the map is, if you notice the name is HashMap, it means it has something to do with hashing. What exactly is hashing, that we will cover later in one of the future videos when we discuss the internal working of the HashMap. But as of now, in simple terms, think about it. It is a way to find a location for an entry. Now, let's go back to the list again. When we add an item to the list, it is added to the next available memory location in the internal array. So if we are at index k, then when we add another element to the list, it will be added to the k plus 1. All right. Now, if we know the index, it's easier to get the value from the array or from the array list, because we can simply pass the index and it can return the value. But if we don't know the index, the downside is we have to perform the linear searching. We have to check each item one by one. If this is the item that we need, then fine, terminate the looping or terminate the searching. Otherwise, we keep going with this approach. Now think about it. What would happen if given a value, we can quickly find the index that this item is located or placed at this index, then we can quickly get that value. That is the concept of hashing, and HashMap is based on that. Given a value, it will always return a certain index that go to this index to get the corresponding value. And so it enables the fast searching. That's why if you remember from the set discussion, that sets are based on HashMap. And that's why I said that it is recommended to use set when we quickly want to find an item, because they are implemented on the back of HashMap, and HashMap is very smart in finding the location because it is based on the hashing. So that is a brief overview of the map in general. So let's move on and see a quick demo on it. So we have this class map demo, and there you can see different operations that map supports, and we will see all of them. Okay, so these are the categories that we are going to cover with HashMap. So let's start. So let's start with initializing a new HashMap. How do we create a new HashMap? To do that, we simply use the class HashMap. Now, if you notice, there are two generic parameters type arguments, k and v. What are these k and v? So k represents the data type of key and the value represents the data type of value. They don't have to be the same. key, so you can have different data types for keys and values. So for example, I need to create a map, and in that map key will be an integer value and the value would be of type string. So what I can do, I can create a new hash map. I will provide the data type of key, which is integer. And one important thing here is that all the data types that we provide to type arguments, generic type arguments, they have to be references. We cannot use primitives here. So instead of int, it must be integer. And the type of value is string. So I am creating a map of type integer and string. All right. Let's name it. Let's say int to string map. And then we do new hash map. Okay, we can provide an initial capacity, but let's leave it for now. If we don't provide initial capacity, a new hash map will be created with default values that we will cover later when we talk about the internal working of hash map. So here we have a new hash map, and in this hash map, the keys will be of integer type and the values will be of string types. Now let's see how do we add a new entry to this hash map, because we cannot simply add the value. We'll have to provide the key as well, and key and values, if we combine them, it's called an entry. So how do we add a new entry? So I say int to string map dot put. So map has put method, and if you see, it accepts the key which is of type integer and the value which is of type string, because we provided the data types in this way. So let's use the put method. I can provide a key, let's say 1, and the corresponding value string 1. Now this is called an entry, and this entry has key 1. It has to be integer, right? And the value string 1, because it has to be string. So we added one entry to this map. How do we add another one? Dot put key 2 and value 2. Now that we have added the entries, let's print the map and see the contents of this map. So we can do sysout and int to string map. Let's run the code. And we see this kind of structure. So you see in the map, it has this key 1 equals to value. So this is the key and this is the value. Similarly for key 2, we see the string value of value 2. So that's how a map would look like when we print the map. All right, moving on. Let's see how do we get a value by the key. So given this map, let's say we need to quickly find the value for key 2. So what we can do, we can call the get method on the map. So we say get, and it accepts the parameter which is the key, because it's a dictionary data structure, dictionary type of data structure. So we pass a key to the map and it returns the value corresponding to that key. So if I pass the key 2, then in the output I should see the value 2 in string form. Here it is. But if I pass a key that's not there in the map, then in that case it returns null, because it does not have any entry with that key. So we see the value null. So that's how we put the entries to the map, and that's how we get a value by key. Now you saw that when we passed a key with value 3 that's not there in the map, in that case map returns a null value. But suppose that we don't want the null value. If the key exists in the map, we want to get the mapped value. Otherwise, we want to return a default value. Because the thing is, when we return a null value, it may throw a null pointer exception. So maybe we want to handle that differently. We want to return a default value. In that case, what we can use the method get or default. So map has a method get or default. It accepts two parameters. First one is the key and the second parameter is the default value. This time let's pass the same key and default value NA. And let's also print the same. So what it will do when we use the get or default method and when we pass it a key, what map does, it tries to find the corresponding entry which has this key. If it finds an entry, it will return the corresponding value. If not, then instead of returning null, we will get the default value. Map will return this default value. So because we don't have entry 3 in the map, so earlier we got null in the return, but this time instead of null, we should see NA, the default value. Running this code for the entry for the key 3, this time we get NA instead of null. So this is get or default. Now another way is, let's say we simply want to check if a key exists in the map. So similar to sets, map also has contains key method. All right. If we want to check the existence of a key, we use the method contains key. If I pass a value 3, which is not there, and if I pass a key that exists in the map, so contains key, let's pass 2. And if we run this code now, we see for 3 it returns false because it's not there in the map, and for 2 it returns true because yes, map contains this key. Given this map, it has 2 entries with keys 1 and 2. So we can check the existence of a key by using method contains key. Similarly, we can also check the existence of value instead of the key. So consider we have the value 1 and 2, and we want to check if this map contains value 1 instead of keys. We can do so by using contains value method. So we can do something like this, 1. And this time it returns true because this map has an entry and this entry has value 1. So that's how we use contains value. Now clearing the hash map is simple. It has a clear method, but before that let's try to use the size and isEmpty method. To print the size, we call the size method, and to check if this map is empty or not, we use isEmpty method. Right now this map has 2 entries, so we should see size 2 and isEmpty false, like this. But now if we clear the hash map by using the clear method, in that case it will remove all the entries from the map, and when this code runs it will print the size 0 and isEmpty true because now the map is empty. So this time we see the size 0 and isEmpty true because we have cleared the map. So let's revert this change. We don't want to clear the map because we have to test other methods as well. Then we have compute, compute if absent, compute if present. We will cover these 3 methods after some time. Before that, let's cover this getting all entries. So we know we can iterate over array list, we can iterate over set. In the same way, we can iterate over all the entries in the map, because map stores keys and values in the form of entry. One entry has one key and one value. To get all the entries from the map, we can use entry set. So entry set, if you notice, returns a set of type entry. So entry is an internal class and inner class of the hash map which represents an entry. It has a key, in this case integer, and a value string. So we can get the whole entry set from the hash map by using the entry set method, which will return set, which is basically a collection. And so we can iterate over this collection in order to get all the entries. So what we can do, we can use for each method, and it accepts a consumer to consume the entry method, sorry, entry class. So let's try to implement the consumer. So this consumer will accept one entry at a time from the hash map, and this entry will have a key of type integer and a value of type string. And it's up to us what we want to do with this entry. So what we want to do is we want to, let's say, print the key, and from the entry class we can get the key using getKey method. Similarly, to get the value, we use the method getValue. All right, and let's replace this with lambda. We don't need the consumer, the whole consumer verbose implementation of the consumer interface. So we are saying that get me all the entries, and then for each entry simply print the key and the value. Let me change the separator, and now if we run this code, so we see all the entries printed in this way. Instead of for each, what we can do, maybe we want to do something else, and maybe there is a complex logic that has to be applied while iterating the entry set. So we can use the for each method as well, because entry set is a collection. Something like this, map dot entry integer and string entry and int to string map dot entry set. So we are saying whatever entry set that we get from the map, iterate over this entry set, and that entry will be stored temporarily in this entry variable. And again, we can do the same thing. To get the key, we would say entry dot get key, and to get the value, we would say entry dot get value. So different ways to use the same thing, different ways to iterate the same thing. All right, instead of for each, for the same set we can use the iterator, or we can use the stream on the entry set. It's up to us. The important thing is, how do we get all the entries from the hash map? And we do that via entry set method. So that's how we get all the entries. Now let's say instead of getting all the entries, all we need is, we need all the keys from the map. Okay, so how do we get all the keys stored in this hash map? We can do so by calling the key set method. Earlier we used entry set method to get a collection back, a set of entries. Similarly, we have a method key set that will return a set of all the keys. So this set will have all the keys stored in this hash map, and again we can do the same thing. This time this will return a set of integer because keys are of integer type. So we can use a simple for each loop, something like this. So what we are saying, get me all the keys, then iterate over the collection using for each method and print each key. Let's run this code now, and we would see all the keys one by one. Here, getting all keys 1 and then 2. In the same way, we can get all the values. So we do this by values method. So here values returns a collection of string, because the values are of string type in this map. All right, so we can get all the values separately. Let's print all the values. And let me run this. and here we see all the values 1 and 2. So three ways. One is to get all the entries. If we want to do something with key and value both, then entry is the way to go. Second way is to get all the keys. If we are only interested in keys, then we can get all the values separately. Same thing. The next operation is for each. We have already seen how to use for each with a map. So first we get either the entry set or key set or values, and then we use for each method. All right. So we are not going to cover this one. What else can we see for now? Okay, remove method. So let's try to remove some values from the hash map. Before that, let me add a couple of more entries. So we say 3 and 4. Now before that, what if we repeat the same key? What will happen? So let's say we add another entry with the same key but with a different value. So I'm adding two entries and these two entries have the same key 4 but the values are different. What will happen first of all? So let's try to see this. And we see that the last value is there because this value has been removed, has been replaced with this value. So if we add a duplicate key in the map, the value, existing value will be replaced with the new one. So we see 4 in caps. Now how do we remove values from this map? Let's say we want to remove this value. So we will say that remove this key and let's print the map after removing this key. So we see that 4 has been removed. Okay, this entry has been removed because we passed the key that I need to remove this key for. So the whole entry has been removed from the map. All right. Then there is another method, remove. It accepts two parameters, a key and a value. So what's with the value? The thing is, we are saying that remove a key, let's say 3, only if the current mapped value is something. That something we provide in the form of value. So what I'm saying is, so we are saying that remove this key 3 from this map only if this key is mapped with this value. So it generally happens when a map is being modified in parallel. So for example, the map had some value for certain key, but by the time I'm removing that key, someone may have changed the value. So this is to make sure that I want to delete this key only if no one has changed the value and that key is still mapped to this value. Okay, so we are saying that remove this key, remove the key 3 only if the currently mapped value is 3, all in uppercase. But if you see, I'm just trying to replicate the same thing. So if you see in this map, this 3 is not mapped to this value. So if we run this code now, it will not remove the key. As you can see, 3 is still there because this condition is not matching. We are saying that remove key equals to 3 only if the currently mapped value is still this 3, all in uppercase, but that's not the case. To verify the same, if we change this, now we are saying that remove the key 3 if the value is this one. This time it will be a match and so the 3 key will be removed. As you can see, this has been removed now. So that's how we use remove and a remove with a default value. So the documentation says that key with which the specified value is associated, and value is basically value expected to be associated with the specific key. All right. Moving on. How do we replace existing values? So I'm saying that I can pass a key and a value. So what I'm saying is that if I pass you a key, for example, 2 and a value, updated value, then replace the existing value with this new one for this key. So if we see there is an existing value mapped with this key equals to 2, which is 2 in this form, and we are saying that update this value, replace this value with all in uppercase. As we can see, the value has been replaced. Similarly, there is another method, replace. It accepts three parameters: a key that we want to update, old value, and new value. New value is something that we want to update, but what about the old value? And the concept is same what we discussed in the remove method. So if a map is being modified in parallel, then we want to update a value only if the value of that entry matches with the old value. That means by the time we are calling the replace operation, no one has changed the map or this particular key. So what I want to say is that update the key to, and the new value should be 2, but only if the old value is 2 in uppercase. So I want to update the value to this one only if the current value of this entry or this key is this one. So as we can see, this map has key equals to 2 and the value is a perfect match. Then in this case, the value will be replaced with this one. And if we run this code, we see that the value has been replaced. All right. Then we have this replace all method that accepts a by function. So let's try to implement the by function. It says that replaces each entry's value with the result of invoking the given function on that entry until all entries have been processed or the function throws an exception. So what it will do, it will apply this function to all the keys, okay, to all the entries, and depending on the output of this function, the value will be replaced. So this is basically key and this is value. So internally there will be a loop on this map for all the entries, and each entry will be passed to this method in the form of key and value. And whatever we do with this key and value, whatever value we return, the value of that key will be replaced with the value that we are returning from this method. So let's say what I want to do is, for each key, if I say if this key is an even number, okay, in that case I want to update the value to this one, even. Else I don't want to do anything, simply return the existing value. So what I'm saying, for each entry apply this function which will check that if the key is an even number, then update the value to this one. I'm simply appending hyphen even, otherwise return the existing value. Okay, let's replace it with lambda. And now if we print the map, So if you see one for key 1 there is no change because this is an odd value, but for key equals to 2 the value has been updated to 2 hyphen even because 2 is an even number. So that kind of thing we can do with replace, or we can pass a function and that function will be applied to all the entries using key and value, and whatever value we return from the function, that value will be the new value for the key. Okay. So let's go to the merge method and let's see in which scenario we can use the merge method. Here it is. We know that a map cannot contain duplicate keys. If we try to add another entry with the same key, the existing entry will be replaced. All right. But what if we don't want to replace the existing entry? What if we are adding another entry with the same key, or if we are trying to add the duplicate key? In that case, we want to merge the values. Instead of replacing the existing value, we want to merge the values. If we want to do that, in that situation, in that condition, we can use the merge method. So let's try to see the hash map, current hash map first of all. And in the merge step, we see at this point of time, the hash map has two entries, one key and second key. Okay. Now, the merge method, it accepts three parameters. The first one is the key that we are trying to add. Second one is the value corresponding to that key. And the third parameter is a by function that has the implementation of the merge method, that if you find the duplicate key, how do you want to merge the values? So let's say we already have an entry for the key 2, and in this example we will try to add the duplicate key, another value for the same key, which is 2, and we will try to merge the values. Let's see what I mean by that. So I'm going to add the duplicate key, and the new value that I'm going to provide is basically the 2 in string form but within uppercase. All right. Now we know if we don't use the merge method and if we try to add this entry, the existing value will be replaced by the new 2 value that I'm providing here. But because we are using merge method and we want to merge the values, so we need to provide the by function. Okay. So this by function basically accepts the old value, or the existing value, which is 2 in this case, and S2, which is the new value that we are going to provide, this one. And it's up to us how we want to merge them. So let's say in this case, what I want to do is I want to merge these two values in this way. So what I'm saying, that if you find a duplicate key, then instead of replacing the existing value, just concatenate the existing value and the new value, and this will be the new value basically. Okay. So let's print the map again and replace it with lambda. And if we run this code now, we see that in the merge section earlier we had this map with 2 keys, but after the merge method this entry has been updated. So for the same key the value has been updated, and it's the same value that we provided in the form of by function. So the values have been merged, and that is the concept of merge method. If we don't want to replace the existing value, but if we want to merge them, we can use the merge method. In that case, all we need to do is we need to provide a by function that will accept the existing value and the new value, and the implementation that we give to basically merge the values. All right. Let's move on to the put all method. Put all is basically there to support the bulk add operation. All it does is, if we see the signature of put all, it accepts another map. So we can provide values in the form of an existing map, and all those values will be added to this map. If there is a duplicate, the value will be replaced. All right. So we can see a simple example of this one, and the type must be same of key and value. So this type would also be of integer and string. New hash map, and let's set couple of values. Six. Let's say we have an existing map and it has some entries, it has some values, and we want to add all these values to the map that we created in bulk mode. So all we need to do is we need to use the put all method, and we can pass this map, and all these values will be added to this map into string map. So if we print the map after calling the put all method, so we go to the put all, we see 1 and 2 are already there because they were the existing entries of the map, but new entries have been added, 5 and 6. So in this condition, in this scenario, we can use the put all method. Consider the scenario where we want to add some value to the map only if it's not there already. So if the map does not contain the key, then only add the new value, otherwise don't. The problem with this step is it's not atomic. First it has to apply the contains call, and then it has to add the value. So it's not atomic, and there could be some concurrency related issues. Now there is another point. If we are so concerned about the concurrency, then we should use another variant of the map basically, which is concurrent hash map, not this hash map. But still, this operation is not atomic because it is checking and then it is adding the value. To make this atomic, this new method was added to the HashMap class, which is put if absent. That means in a single step, put the value only if it's absent, otherwise ignore the value. So considering that we have this hash map, as we can see, we have keys 1, 2, 5 and 6. We don't have a key 3. So let's try to add the key 3. Because this map does not have a key 3, so if we are trying to add it using put if absent, we should see the key added to the map. So we call put if absent, it accepts a key, in this case 3, and we are passing the value 3. And let's also print the map. And if we go to the put if absent, so if we go to the put if absent section, we see 1 and 2 were already there, 5 and 6 were already there, but this new entry has been added because it was not there. So put if absent checks if the entry is not there, if the key is not there, then only add the new entry. But if we try to, for example, say that put if absent, and if we provide an existing key, let's say 2, with some gibberish value, then it won't be added because 2 is already there. Let's verify that. So we see in the put if absent section that there is no impact on the existing entry with key 2. So we see that this call was basically ignored because we already have the entry with the same key. All right. Now there is one important thing with put if absent, that if the key does not exist, in that case it's fine, it will add a new entry with the same key and the value. That's fine. But if the key already exists in the map, so in that case it won't update the entry, it will not add the new value, but whatever value we are providing, it will be initialized. So in this case, even though this call was ignored, but it still created a new string object. All right, that problem is solved by the compute methods. Compute if absent, and compute if present, that we will see next. Now compute if absent is similar to put if absent. The main difference between these two methods is that in case of put if absent, the value is eagerly initialized. So even though if it finds a duplicate key and it won't add the value, but even then the value that we are providing will be initialized. So it will create a new object every time. But in case of compute if absent, it initializes the value in a lazy manner. So if the key does not exist, that's fine, the value will be initialized and added to the map. But if it finds the duplicate key, so it knows that it doesn't have to add the new value, and because it is initializing the value in a lazy manner, in that case a new object will not be created. Okay, so let's see an example of compute if absent. This is same. We provide the key, then we provide a function, a mapping function that will return a value. So let's say for a new key, 7 is not there, so we can use 7. We want to add the key 7. Now this key is absent, so it will or it should add the value. All we need to do is we need to provide the function. Okay. Now if you notice that the function accepts the key, and based on this key we return a value. However, if we see the put if absent method, then there is no such restriction. We can return any value. It does not have any dependency on the key. But in case of compute if absent, the function that will provide the value, it uses the key that we are trying to add. So let's verify that. If I basically print the key here, or the value that is being passed to the function, and for the time being let me return the same value. Sorry, it must be string. So we say string dot value of, and so we just want to see what kind of value is there, what value is there that is being passed to this function. And if we run this code and go to compute if absent section, here, so we see 7. That means it is passing the same key, and we need to use this key, all right, to create a value. That is another difference between compute if absent and put if absent. So 7 is not there, so it called the function to get a value, and because in this case we are simply returning the string value and printing the key, so we know that it passed the value 7 or the key in order to get the value. But what if we try to add an existing value, which is 2? In that case, do we still see this println? Let's verify that. If you go to compute if absent, then we don't see anything, because as I said earlier, compute if absent initializes the value in a lazy manner because we are passing the function. So it saw that 2 already exists in the map, so it does not call this function because it knows it does, because there is no need to add the value, there is no need to add the value, so it will not call the function to get the value. That is the main difference and advantage. But the downside is the value generation part is dependent on the key. All right. Now in this case, because we are returning the string value of the integer, so let me change it to the new value. In that case, if we print the map, then we should see the entry with key 7. Compute if absent, and we see the map. For key 7, we see the same value. The only difference is of data type. So we saw how compute if absent works. Compute if present is basically same, just the opposite. So if we want to do something, if the key is present in the map, then we use compute if present. All right. Now let's try to use the compute method. So compute method also accepts a key, which is basically the key that we are trying to add, and a by function. So first let's try to add the same key or an existing key 1 and new by function. So you see how compute differs from compute if absent is, in case of compute if absent, the function that we pass to get the value depends on the key only. Let me change it to lambda. Okay. And let me remove this one. So the function depends on the key. But in case of compute method, it is a by function. So the value is dependent on the key and value both. It's up to us how do we want to use it. Okay. So let's try to see the values passed to this by function. So we can print integer, which is basically the variable name, and s. Okay, and if we run this code now and go to the compute section, then we see the integer, which is the key, is basically 1, and s is the existing value because map already has the entry 1 and the value 1. So that's what we see in the compute section here. Now it's up to us how to return a value. So what if we do something like this? We say integer plus some separator and value. So that's what we want to return. And if we print the map and if we run the code and go to the compute section, then we see the value for key 1 has been updated because that's what we did in the by function. Okay. Let's replace it with lambda. Now, what if we try to add a non-existent entry? 9 is not there, so let's see what happens if we try to add a completely new value. In the compute section, so we see 9 hyphen null because there is no mapped value. There is no mapped value, so it was able to retrieve the key, which is this, but because there is no value, all it did, it basically appended the null. Okay. So just to revisit, the compute, in case of compute method, we provide a by function, so it can use the key and value both to generate a new value. In case of compute if absent, this is a simple function and it uses the key to generate a value. All right. And if we go to the put if absent, in this case, the value is not dependent on anything. We can pass any supported value here. Okay. So that covers all the operations on the hash map. The only difference with linked hash map is that it maintains the insertion order. That's it. How do we initialize it? To initialize a new linked hash map, all we need to do is we need to use the class linked hash map. Provide the data type for key and value. So let's say we want to create a new hash map, linked hash map with the same data type, string and string. and we name it map, new linked hash map. That's it. Apart from this, everything that we saw with the hash map applies to linked hash map. It supports all the operations. So that covers a demo on the hash map and linked hash map.